So, hi everyone. Welcome to the 5th Arduino Workshop. Hope you guys are all doing well. Real briefly, for those of you who weren't here last time, we were talking about a problem with Arduino is that basically so far every code that we've written, it's been like a list of instructions that the Arduino has to follow. Do step 1, step 2, step 3, you get down to the bottom of the loop, you jump back to the top. And the problem with that is that, say you're in the middle of step 2 and you receive an input that you want to, like step 3 is reading an input, but you're in the middle of step 2 and then the user pushes the button, well, the program is still at step 2, still processing step 2, it can't do step 3. So it wouldn't receive the input and then your code would be erroneous. So what we did last time was, instead of doing the step 1, step 2, step 3 mentality, we kind of had conditions and we based that based on time. So we could read how much time had passed, and in our classic example of turning an LED on and off, instead of turning it on, waiting a second, turning it off, waiting a second, we turned it on if so many seconds had passed. And then every single loop we checked how much time had passed, but that checking how much time has passed is really quick, and then you can do other things, versus a delay of 1 second. You're in that, the Arduino has to process that delay the full second and can't do anything else. So that was a way to move away from delay, but as I said, it's also not perfect. You can still be doing other things when the button is pressed, and the user presses the button that's not delaying. Maybe on a robot car, it's doing the math to compute what the steering angle should be to make a corner. So it's all math, so it can't just, there's no way to get rid of that computation time by removing a delay, but then the user still presses a button in the middle of that, and we still want to detect that. So that is how we're going to do that, is we're going to use interrupts. So interrupts, basically it transfers control from a main loop that we have to some other function, sometimes called an interrupt service routine, or ISR. There can be hardware interrupts, such as any input, a push button, some serial data coming into a port. There can also be software interrupts like timers. So interrupts are useful because they can save computational power and they solve a lot of timing issues, which is kind of what we're focusing on today. Instead of just constantly waiting for a user, say the Arduino is expecting the user to press a button, instead of wasting a lot of time sitting there to see if the user ever presses the button, who knows, it could be minutes before the user does that, and every single time the Arduino has to check that for a little bit of time, we can do it using interrupts, and then the Arduino can do other work. So the graph on the right is kind of an example. We have the process executing, which is basically what our normal code is. There's this external event, so we're going to jump to an interrupt outside of the code, handle the interrupt, and then jump back to executing the code. I think to illustrate the point of this slide, I'm going to just draw this out on a whiteboard, because that would be easier. So we're going to have setup. So up here, declare functions, just put that in comments, or not functions, declare variables. Setup. So this is kind of a refresher of a lot of things that we learned. But this is one way to like set up your code, and kind of what we've been doing for the first 3 or 4 lessons. And it was kind of the steps, the instructions that the Arduino has to follow. They come in a sequential order. So as we talked about before, you declare your variables at the top. You do the void setup to set up some of the hardware on the Arduino, and then you get to your loop, and then you have steps. Maybe there's this first function that you want to compute, then a second function, then you go back up to the top, and you just do this forever. And then down here, you declare the functions. So as I talked about before, pitfall is if these functions require inputs, and you're in function 1 when the input for function 2 is sent to the Arduino, you can't read that. So we want to fix that somehow. So another method would be this polling method. And this is if every single function that you want to use is triggered by some sort of input. So you could do if, we would read the push button, but I'm just writing pseudocode here. If and we'll pretend that I still have these written down here that I just erased. But this is polling, where in your void loop, you don't actually do anything except you have several conditions that are checking the status of your inputs. So in your loop, it's just spinning, it's checking, checking. Then the user presses the button, okay. Now we jump from this condition is true, so we jump down to function 1. Jump down to function 1 and process that. So by doing it this way, most of the time, in most situations, you're going to be constantly processing this is very quick. So even if you're pressing the push button as the Arduino is on this step is going to take a very small amount of time for the Arduino to actually process. And very quickly it's going to jump back up to here before you have a chance to even release your finger from the push button. So using this method, you're almost always going to catch the user input and then be able to process it. The only pitfall, once again, is if the user presses the push button and then you jump down to function 1, it's doing its processing, maybe some math, and then the user also flips the switch while you're down here, the Arduino is not going to be able to recognize that. And then by the time it jumps back to this void loop that's constantly cycling through, the user might have released the switch, and then the Arduino never processed that input. So the final thing is using interrupts. So in this instance, we actually don't have anything in our void loop. I don't know how you would say this in pseudocode. Say declare. So we'll talk about in a minute how you actually write this syntax for the Arduino. But basically what you would do, I can't remember if it's in the setup or if it's even before the setup. I think it's in the setup. You basically declare that our push button pin is going to be an interrupt. And when that interrupt happens, we're going to go to ISR1, which is interrupt service routine 1. This is just a function. You can name it whatever you want, and then put that down here. And then we also are going to declare the switch as an interrupt. So we're going to call that ISR2. So what happens is if the push button is pressed at any point, you're going to jump down here to ISR1 and start processing that input. And if the switch is flipped at any point, the Arduino is immediately going to trigger. It's going to jump down to ISR2. So say we want to do a third thing of, say, math. You do a lot of math and coding. And so in the loop, you're doing a bunch of math. It's taking up a lot of time. And you're on this instruction when the user presses a push button. What the Arduino is going to do, it's going to finish processing this instruction, but then instead of jumping down here, it's going to jump down and process this function. And then when it's done with this function, it's going to jump back here. Does that make sense? And then depending on how you set the priority of your interrupts, which I don't know if the Arduino actually allows, but if you're in the middle of this function, when you press the switch, you're actually going to jump out of this and go to interrupt service routine 2, process the switch, and then jump back to where you were in this function. So that is something you have to think about. So the final way to do this, because when you're in the interrupt service routine, you're not in your main code. You're handling this. Actually, I don't know. Do you know, Andy, if while you're in an interrupt service routine, you can handle another interrupt?
Yeah, interrupts they're non-reentrant. See, an interrupt can't interrupt itself.
Mm-hmm.
But like, one can interrupt two, which I think can then be interrupted by one step. No, it can't. So you can do like 1, 2, 3, or like 3, 2, 1.
Well, I know, like in a real microcontroller, you can have priorities. I don't know if that works with Arduino.
What do you mean? Oh, like priority.
Yeah, you could say like this is priority 1, and this is priority 2.
I mean, and there have to be priorities. I don't know if you can change them, but there are built-in priorities.
Well, let's say in most examples, the Arduino is going to recognize that an input has changed, like the push button, the switch, anything. It's going to have to recognize that and then handle it, either do math or do some sort of output, print some sort of statement. And we always want it to catch the fact that it's happened and recognize that. But sometimes what it's going to do next does take a bunch of time. And because while we're in this interrupt service routine, we're not handling our main code, which might throw timing issues in here, we want these interrupt service routines to be as short as possible. So the final way to do this is a combination of interrupts and polling, which we'll kind of do for the last example. You guys can see with my terrible writing. Okay, we'll keep So in this example, this math is important, and we don't want to spend too much time in this interrupt service routine and not handle this math. So what we're going to do is we're going to make these service routines very short, and all it does is it sets a flag, and the flag would just be a variable that we declare up here. So we set up, so say we're right here, we're doing the first part of math, and the user presses the push button. Once this is done, before we go to the next step, we're going to jump down here, go to this function. In this function, all we're going to do is set this variable called flag1 to 1, or set it to high. Then the interrupt service routine is done, and we're going to jump back here. So what the Arduino has done is it's recognized that the button has been pressed, but it didn't immediately do whatever the next step is, like what you're supposed to do when you press the push button. But that's okay, because then we're going to jump back in here, we're going to handle these instructions, and then when we get to this if statement, flag 1 will be set, so then we can process what we're supposed to do when the push button is pressed. So that was kind of 4 different methods. Just, I don't know what you would call the first one, just kind of like the instructions or the steps, what we've done before, the polling method, then using interrupts, and then using interrupts and polling combined together. Any questions about that?
I have an answer to your question earlier.
Sure.
So the Arduino, so I forgot, each processor's architecture is going to be different for how they handle stuff like interrupts. So like this is very different than how like a laptop would handle it.
Yeah.
So I know it's very different from that. But at least for the Arduino, like AVR, I think is the name of its architecture. Whenever you enter an interrupt, it disables all other interrupts.
Okay.
Which helps avoid racist. You can turn them back on if you want though. So you could have an interrupt, but it's turned off by default.
Okay.
And then
that makes sense.
What that means for priority is that whenever it's in an whenever interrupts are disabled, basically, so that's either if you're in another interrupt or if they're just disabled for some reason.
Mm-hmm.
That just changes the queue. Like it has a FIFO queue of interrupts that were triggered in the meantime, and the priority just changes the order that those are service.
Okay.
But you can't change that. So.
Interesting. Okay. Yeah, so then you would never deal with the, what is it? The critical sections.
Essentially, Arduino essentially automatically, if you're in an interrupt, it automatically creates a critical section. You can turn that off if you want.
Okay.
Which will be necessary for some things, but
okay. Cool.
Like I said.
Cool. Okay. All right. Well, yeah. So, any questions? We're all good. Okay. Well, then we're gonna jump. Oh wait, no. We're gonna talk about some stuff. Okay. So, the next example we're gonna do with the physical Arduino is lots of LEDs, because LEDs are fun. You have 2 LEDs. One's gonna flash at a slow fixed rate, and then the second LED is going to turn on or turn off whenever the user presses the push button. So that's what we're going to do. This is the syntax for how you create an interrupt. This attach interrupt, and then you say the pin that you're using, the ISR interrupt service routine, that's just the name of the function that you'll declare down at the bottom, and then the mode. So there's different modes, basically different ways the Arduino can recognize the interrupt condition. There's low, if the pin is receiving 0 volts, it's low. Change, if it goes from low to high or high to low. Rising, if it goes from low to high. Falling, if it goes from high to low. And so besides the first mode, all these other modes, say you press a push button, the interrupt will only trigger once. Say you press the push button and it goes from a high state to a low state, then that only triggers the interrupt once. And even if you hold the push button, the interrupt only triggered once. But that's normally how we want things to activate when we're dealing with interrupts. Normally it's like some condition changes, we process it, and then we wait for that condition change to happen again. So then you guys are going to wire this up. Yet again, we're going to wire up 2 LEDs, and we're going to wire up a push button. If any of you guys forget the pull-up resistor for the push button, I'm going to be sad. So, yeah, this shows that using interrupts, we can register an input and from the user, or like in a robotics application from the environment, say the robot's driving a straight line and it has a toggle switch on the front. So if it runs into a wall, it should stop. You don't want it to run into the wall and then the Arduino to spend a little bit of time before it actually registers that it ran into the wall and it's driving. We want that to be an interrupt, and it triggers as soon as it happens. And like I told some of you guys, in this example, because in the interrupt service routine, we only do 2 instructions, it's really quick, we can just put that all in the interrupt service routine. In the next example, we're going to do something that's a little longer, so we're going to want to set a flag and then deal with it in the main loop. It works? Let's go. We achieved 100% success, right? That may be a first for the Arduino Workshop. So what we're going to do now is like do a code along. So I'm going to type up on the screen, and you guys are going to follow along, and we're going to explain it step by step as we go along. And what this example is say the Arduino is doing something, but then it also wants to be able to register if the user sends an input. So using the serial monitor, I go over here. See Zach?
Yeah.
Love you all.
Using the serial monitor, as we've done in previous classes, you can print things to the serial monitor and read that, but also you can type in here whatever you want and send that to the Arduino. And so what we want to do, I can actually show what we want to do. What we want to do is open up a serial monitor. On our Arduinos, there'll be like an LED blinking, which in this example and the previous example, this LED blinking, we could use the millisecond function and speed up what the void loop does. But basically what we're using as an example is that if we have a lot of processing going on in our void loop, and so the delay of 2 seconds or 3 seconds kind of simulates that, although ideally we want to get rid of as many delays as possible. But so in this example, the Arduino is doing something else. It's blinking an LED, and then if the user types in a message, we want it to print that message back. Now, so that's kind of the goal. Now, it may not print it back immediately, but that is how it's going to happen. The other thing we need to be concerned about is why we're using an interrupt is we have so we're sending a serial signal through this wire to the Arduino, and on the Arduino, in the physical hardware, we have what's called a serial buffer. So using ASCII, each letter is represented by an 8-bit number, and our buffer can store a certain number of those characters, but it can't store an infinite amount. Eventually, if we keep sending it a bunch of characters, the buffer is going to overflow, and it's going to lose that unless the Arduino has already registered that. So say in here we type a really long string. This is important. This means something. We send this really long string with a lot of characters, and say we send it while the LED is blinking on for 3 seconds. If this is more characters than the serial buffer can hold, it's going to forget the first couple characters as new characters are coming in. And that's bad because then we're losing part of the message. So what we need to do is every once in a while check to make sure that there's nothing on the serial buffer, and if there is, take whatever that is and put it in a variable and store it. And this ensures, if we do that quick enough, this ensures that even if we send a very large message, we're not going to lose any data. So that's the goal of this workshop part. So you guys can keep what you have wired up the way it is. We'll just probably use one of those push buttons. Delete this. You guys can open up a new Arduino sketch. And the first thing we're going to need to do is add a, oh, this is annoying. Why is it doing that? Sorry. It's opening up on this thing. Okay, so we're going to go to Sketch, and you won't be able to see it. And then we're going to go to Include Libraries and Manage Libraries. I can't see how I did that. But if you remember before when we added a library, we can go to this screen. So it's Include, Manage Libraries. I forgot the steps. Sketch, Include Libraries, Manage Libraries. We'll get to this screen. Is everyone here?
Yes.
So then we want to search timer 1. And if we click on it, there should be an option to install. Because I've already installed it, I don't have that option. But if you hover your mouse over it, it says timer 1. There should be an install in the bottom right corner. So basically, this is going to be a software timer that allows us to create an interrupt based on what time it is, how much time has passed. So has everybody installed that library? Good, good. Laura, you good? Jane, you good? All right, and then we can go back to Sketch. It's really annoying, it's showing up on my screen. Go back to Sketch, go to Include Library, and scroll down until you see timer 1. And then once you click on that at the top, you should see hashtag include timer1.h. You can also just type that if you want. That may be easier. So we've included the library that we need that has all the functions that we need to deal with the timer. Now we're going to set up some variables. So we're going to declare a LED. We'll set that equal to pin 13. We are going to declare 3 different strings. Print. And obviously these names don't have to be this, but you'll have to be consistent throughout the whole thing. And I like to choose long names that explain what it does. Well, saved. So we have 3 different messages, or 3 different strings that can hold a bunch of characters. And they'll hold various stages of the message that's being received and being sent. Now we also need a variable to store a single character. So that's the data type char. And then we're going to have an int. Oh, you can see it better up here. Okay, you can sit right here if you want. Evan, can you see it fine? I know it's slightly hard to see.
Yeah, I need glasses.
I can probably make the text bigger somehow, but
Turn off the lights maybe, or
yeah, you could do that.
that's a bit better, I think.
Ups a little bit, okay. So then we want to create a variable that's basically the flag. So as I talked about before, the structure we're going to use is the polling with interrupts. So in the interrupt service routine, we're going to do just a little bit of code, and then we may set a flag, and then the rest of the processing power will happen in the void loop. So we don't take too long in the interrupt service routine. So we're just going to declare a flag message received. We're going to set that equal to 0. And we're also going to declare a function up here. So, forget the terminology. We basically just declare that there is a function up here, and then at the bottom, we're actually going to declare what that function does.
Function declaration.
Function declaration, and then what do you call it at the bottom when you actually fill it in? Definition?
So it's declaration.
Oh, declaration, definition.
Yeah.
Okay. So, does everyone have all those variables? I guess, does anyone not have all those variables? Okay, well then we'll move on to our setup. So in our setup, we need to start declaring the hardware. Node D output. Now we want to start the serial port so the Arduino can read what the user is typing, and then the Arduino can also send messages back to the serial port. Do you guys remember how we start that process? What do we have to do in the setup?
Serial.begun.
Yes. Begin.
You guys did not do that at 69, did you?
He did.
Oh my god.
What?
Nothing. Never mind.
What's wrong?
Talk about it after we're done recording.
Yeah.
Yeah,
The video
we
doesn't get
monetized for
canceled.
69.
Wow. What's next, Joe?
So yeah, so we do the serial begin, and then we just declare the baud rate. We'll do 9600. We'll throw in a short delay, just because, so we have time to finish the serial declaration. And then we're going to use some of the syntax, some of the functions that we received from the timer1 library. Initialize. So we'll do timer1 initialize, and we're going to set that to 1000. So I wrote a quick note saying that this is not in milliseconds like what we're used to in like the delay function. This is in microseconds. So 1000 microseconds actually equals 1 millisecond. So basically what this does is now we have a timer, and it's going to trigger every 1 millisecond. And then with that, we can attach an interrupt similar to what we did before and set that equal to a function. And so now we're done with the setup. So hopefully that all makes sense. Probably just the new stuff is the timer1 is initialized, and we set a certain amount of time, and then we attach an interrupt that'll trigger every time 1 millisecond has passed.
What does that say after the interrupt?
Read serial message. So that's the name of the function, and we're actually going to skip the void loop for a second and declare that function. Read serial message. So in every millisecond, we're going to jump down here and we're going to check if a serial message has been sent. And to do that, we're going to do if serial.available is greater than 0. So what this does, the serial.available just tells us if there's anything in our serial buffer on the Arduino. If there isn't anything, then we want to jump out of this interrupt as soon as possible, this interrupt service routine as soon as possible. We don't need to do anything if the user hasn't sent anything. So all our code's going to go within inside this if statement. Then if there is something, that has been sent, we want to capture that. and we're just going to do a single character equals serial.read. So our single character is a char character. It can only hold one character, and we're going to capture the character that was sent the soonest. So say the user sent a string hello, and it's been sent to the Arduino. The first time we called read serial message, this single character will equal the h. It'll equal the first value, and then that h can be removed from the serial buffer, and that will help reduce how many characters are in the serial buffer and reduce the chances that it overflows. Then what we're going to do, in this example, we need some way for the Arduino to know if the message is done. So what I'm going to set the requirement that the user has to put a period when they're done with the message being sent. So if the single character received is a period, then we've received a whole message. Wait a minute. Oh yeah. Okay. Actually, so yeah, if the period has been received, we received a whole message. If we haven't received a whole message, we'll do this first. Message. Sorry, I can't talk and code at the same time. So if we receive the period, we have a whole message. If we don't have a whole message yet, then what we're going to do is we're going to keep adding the characters that we're receiving to the end of a string. And so we have the 3 strings. The message being received string is basically the string that is currently being built. It's the message that's currently being built that's currently, the characters are currently being received and added onto the end. So when we do a string.concat, what we do is we basically add whatever character we put in parentheses to the string. So by doing it this way, whenever we receive a character, if it's not the end character, we're adding it onto the message. If it is the end character, what we're going to do is equal to this string that we're going to be we've been building this whole time. We're going to actually set it equal to another string, the message completely received, which means that this string is a whole message. It's the latest message that has been captured. We can now reset the message being received equal to nothing, basically, because now we want to set that empty, so the next string or the next characters that start coming in will equal the next message.
Is it setting it to like null?
I think this is basically setting it to null. Oh no, if there's like a specific null character, you can set it to too. Yeah, sorry, I don't know off the top of my head. I think this basically serves the same purpose, because normally in here you type your message, and since there's nothing, it's basically set to null or to blank, to nothing. So now we've received the whole message, and we're still in the interrupt service routine. So when we receive the whole message, we want to send that back so the user can see what they just typed. Now, this example that maybe doesn't make the most sense, but one thing that I'm thinking about for this example, and maybe if we have enough time, if we can connect the Arduino to an LCD screen, the Arduino could then print whatever message the user types to the LCD screen, and then that would make more sense. But a printing like that, either a serial print back to the computer or printing a message onto an LCD screen, that's going to take a lot of time. And we don't want to spend all that time in this interrupt service routine. And one reason we don't want to do that is if we're doing that in this interrupts can't call themselves. So if new characters are coming in, if the user sent another really long message, we're not going to be capturing that. So what we want to do is we want to handle this outside of the interrupt. So this is where we set our flag. Our flag message received is equal to 1. So remember, we've declared this flag message received equal to 0 up here. Here we're going to set this equal to 1. Okay, and then we're done. Does that interrupt service routine make sense? Okay. So then up here in our void loop, we're going to do it. We're going to set a condition if flag message received. If we've received our flag, or if the flag has been set, then we need to print something. If it hasn't been set, we're just going to do digital right. We're just going to turn the LED on and off. And this represents that the Arduino has other things it needs to do, that it needs to spend time on. Okay. So yeah, in a real world example, this wouldn't simply just be flashing an LED on and off. Remember, we can get rid of these delays by using the millis function, but in this example, this just serves to represent something more complicated. So now inside of our condition, this is where we actually want to print our message back to the serial port. So we have this third string, message to print equal to that. So we're going to set that equal to null. Actually, yeah, I don't know if that's actually necessary, but I was having trouble, so we're going to just keep it just to be safe. So what this is, it is basically kind of a handoff, and we need these three variables just to resolve some of the timing issues. So the first string that we had, what was it? Message being received. We want to empty that as soon as we have a new message, or a full message, just so that it's free if new characters start coming in. So that's why we empty it down here in the service routine as soon as we pass the message on to the next string right here. Now this message completely received, we also kind of want to empty that as soon as possible. So then down here, if a new complete serial message has been received, we want to store that somewhere. So up here in this condition, we pass this message completely received off to this message to print. And then this variable is what will actually send this string back to the serial port or back to the LCD screen. So that's kind of what this handoff is, and we just want to make sure that whenever we're done with a string that's passed it off to the next string, we set it back equal to null. I didn't do this the first time, and so whenever I sent a second or third message, it started printing out all the messages back, which we don't want to do. So we have this, and then what we're going to do, we're actually going to stop the timer for a second. What did I say? So once we've received the full string, we then want to print back to serial. And that's going to be handled in this print to serial function. But there's a chance that while we're doing this, we're going to receive a new character, or while we're doing this, every millisecond, our timer is still going to be triggering, and it's going to want to jump to the interrupt. In certain cases, there may be blocks of code that we need to execute all at once. We might be like in the middle of sending characters from the Arduino back to the computer through serial, and then we get interrupted to do something else, and now our message is kind of corrupted. So what I've done here is I basically stopped timer 1 for a second, not a literal second, but I've stopped timer 1, I've allowed the Arduino to print back to the computer, and this ensures that nothing will interrupt that. It won't be stopped while it's in the middle of sending a message and get that message corrupted. And then once that's done, timer 1 will restart. And it's okay if we stop the timer and we stop going to grab characters from the serial buffer for a little bit, because we have that serial buffer. And the serial buffer will start filling up, but as long as this print to serial doesn't take too long, we'll start the timer again, and then we'll start grabbing those characters again. So then that's done. So if our flag's set, we do all that. Then finally, there's one last function we have to write. Void. So this is all we really need to do. Whatever our message is, we print that back to the computer. Now, the reason I set this up as a separate function is because it's good coding practice, but also if we do have enough time, or if later you guys want to mess with it and you want to try to connect it to an LCD screen, then we just need to change the code in here. And whatever code you need to send a message to an LCD screen, we just add in this function. So, yeah. Do you guys have any questions about this?
Yeah. What does the serial dot available do?
That just checks if there's a character in the serial buffer.
Okay.
So I guess maybe a way to visualize it is, I guess I'm not for sure the exact order, but just a way to visualize it. Let's say this is our serial buffer. In this example, it's pretty horrible. It only has 4 spots. And then say the user types hello world, period, and then sends that at here. For clarity, we'll send it this way. Andy, you may know this. When the first character comes in the serial buffer, is it put in the first spot and then it jumps up to the second spot when the next character comes in? Or
Generally, things in memory will grow down. Because
Yeah, I guess
memory
that's
addresses are lower at the top and higher at the bottom. But that's just a visualization.
But, like,
it's actually left or right.
would it be H-E-L-L and then, oh, that's not good. Then when the O comes in,
No.
does everything shift up? And the O would go right here?
Generally, we overwrite the first one.
Oh, they'd probably just be a pointer, right?
Yeah, it's just a ring buffer, if you know about ring buffers.
Okay. Well,
So yeah, it's just gonna rotate over and over again.
so we'll have one pointer that like points to the first location, and then when this gets overwritten, it'll move down here.
Essentially, generally there's 2 pointers, one for reading, one for writing, but that's
Oh, yeah, yeah.
essentially what it is.
Okay, well, we'll ignore the second pointer for a second.
Yeah, it doesn't really matter for your example.
Yeah, so in this example, yeah, these characters are coming over serial, and with our 9600 baud rate, that means we send 960 or 9,600 bits per second, which I guess doesn't really translate to letters. But we send in one letter, and then the next message we send in another letter, and another one, and another one. And so the first time this H comes in, second time this E comes in, third time this L comes in, fourth time this L comes in. Well, now we have this last character, this O, and this O doesn't have anywhere to go, so what we're going to do is we're going to overwrite the oldest message and put the O in. And basically, what the serial buffer is saying is, I have nowhere to put this, I'm just going to put this with the oldest letter, hoping that you've already done something with it. And if you haven't, I got nowhere else to put it. This new message is probably more relevant than the old message. And so in that way, then our original message starts to get overwritten, well, like this. And so what we need to do is say at this point we check serial available. Because we do have things in the serial buffer, it'll return true. It'll return greater than 0. And then we're going to grab this first message, or first character, out of here. This pointer that points to the oldest message will now go down here. And now we have more space in our serial buffer. So we have somewhere to store this O. And so as long as we're grabbing characters quick enough, we'll clear the serial buffer before it gets overwritten.
Okay.
Yeah. Any other questions?
I do have something to add if nobody else.
Sure.
Okay, cool. So this is cool. This is basically what I'm doing on TinyCart right now. The only difference with how I did it versus this, which is actually relevant to this, is that, and Arduino has this too if you want to use it, is that there is a specific interrupt for if there is information in the serial port. So it's URX1, I believe, or 0.
There's like a UART interrupt.
Yeah, so
Okay.
basically what I've done in mine is instead of pulling on the main thread with a timer, what I've done is instead have an interrupt that handles whenever there's a character in the port, and then I add that to the buffer basically exactly like Joe did.
Okay.
But in that way you essentially have 0 overhead because you can get rid of that timer entirely, and your processor is literally asleep and it's consuming very little power except for when you're receiving or sending. So that's just another way to do this.
What's
So that would be more of like Joe, in Joe's little notation, Joe's strategy would be like a pulling in interrupts. The
Joe
way I described
notation.
would be pure interrupts without pulling.
What's that called? That library?
In library.
Or so this is with the
It's just
Arduino?
yeah, it's just a raw interrupt. It's like UART RX or something. I just saw it in the list of interrupts on Arduino. I don't know if it's accessible at a library level. I think it is. I think it's like UART.attach or something. I could be wrong though. I haven't used it.
Okay. I didn't check specifically like recently for this workshop, but I thought I checked before and there wasn't something like that for Arduino.
There is at least at a low level. This is something else I should mention. Arduino has like kind of 2 levels of access, like a library level and like an actual like microcontroller level. So for interrupts especially, like this attach interrupt is actually like a high level abstracted Arduino-wise
Yeah.
around it.
Yeah.
There are some things you can't access with it. This might be one of them.
Maybe.
So
Okay.
you would have to like manually unmask the interrupts
Hmm.
and like manually add the interrupts, which isn't honestly that hard. It's just a bit more involved than what was shown today.
Okay. Do you mind sending me your code for that? Or is it on GitHub?
I go for it doesn't. I mean, it's not an Arduino, so I don't know how relevant it's gonna be. I can't anyways. But
It's what?
It's not an Arduino.
Oh, it's not an Arduino.
No, I don't know.
But you're putting it on the Arduino. You're putting it on the Pico.
Yeah, I mean, it's just running on the Pico outside of Arduino. It's just raw.
Okay, so it might not be something that the Arduino has. It might just be for the
No, I
Pico.
looked it up. The Arduino does.
Okay. Okay, I'll do some more
I'll see
research.
if I can find something.
Because I guess for everyone, what I want to do for the last workshop is basically this example, but the user sends a speed command, and then that goes to the Arduino, and the Arduino processes it, and then changes the speed of 2 motors, which there's 2 motors, it'll be a diff drive car, so it wouldn't be like TinyCart, but the general idea would be there. And then if you want to take it one step farther, you replace the user sending speeds over serial to a processor or a NUC sending speeds over serial. And so if there is a UART interrupt, that would be better to use.
Yeah.
I'm not. I didn't know if there was one or not, so that's why I stuck with this timer example. But anyway, so no other questions? Okay. So I put one logical error in this code, so someone can find that.
What do you mean logic?
It's not a syntax error. It's just either something I did incorrectly or something that's missing.
Is it not declaring read serial message?
Read serial message. The flag?
Because you have where. Because in timer 1 dot attach interrupt read serial message. Where is that?
That's right here.
Oh, I see.
So what we're
It didn't. Okay. Never mind. I take it back.
yeah. So basically, this is just saying when 1 millisecond has happened,
No, yeah.
we're gonna trigger this function, and then we declare what happens. This function description is down here.
That's a definite. Or
Def-
that's the
declare.
That's not the declaration. Yeah, that's the definition. Yeah.
Yeah.
Okay, function definition's down here.
Is it like the if single character is equal to dot inside the if?
Oh, no, right here.
Yeah.
Right here. What do you think is wrong with this?
Nothing.
Well, yes, if you go line by line through the code, eventually one of these may be incorrect. So single character is a char, and we're setting it equal to another char. Or no, we're not setting it equal. We're comparing it to the char that's just a period. And when we do a comparison like that, we need to do 2 equal signs. And then when we set a variable equal to a value, we do 1 equal sign. So this is correct.
On the line where after the if single character, we have message completely received equals message being received,
Mhm.
but did we define message being received anywhere? Or
So we define that up at the top.
but it's kind of just nothing right now.
Yeah, we could initialize it to nothing, or we could just, because it would probably be best practice to initialize it to nothing, but because we always set it equal to something before it's used, it's okay to not set it equal to something up here.
Okay.
But we could do this
Oh,
for all of these strings.
so that's just the same, basically. Or
Not exactly. So if we did just have up here string message being received, and then the very first thing in our void loop is print message being received, it would throw an error
okay.
because we declared a variable and then used it before we set what that variable is equal to.
Mm-hmm.
So yeah, we could do this. But that's not the error itself, but that's a good way to improve the code, I guess.
I was gonna say I would add that for single character as well, and make that null.
Yeah.
Because what happens if it actually isn't a problem in this code because we ensure it's always read from, but this is something I see like home a lot, is if you read that char before you write to it, that's reading from just arbitrary memory and it'll cycle the program. So it's just
Yeah,
in practice
yeah.
in C++, to just always assign it.
Good call. Good call. I'll give you a hint. We're missing something in the void loop. And I guess that narrows it down because just right here we're just messing with an LED and this is fine. So we're missing something here. If
If once it's received, you have to set it to not received again after you're done.
yeah, exactly. So this flag, right now what would happen is we'd start the code, the user then sends a message. The first time a full message has been received, down here in this interrupt, we're going to set flag message received equal to 1. We'll jump back into the loop. Maybe we're in the middle of blinking this LED. That's okay. Once we're done blinking the LED, we would jump back up here. then we'll check this condition. If flag message received is 1, it would be. We would handle that, but right now we don't set it back equal to 0. So the next time we go through the loop, this condition would be triggered, even if it shouldn't be. So yeah, just in here, the very first thing we need to do is flag received equals 0. So then we'll verify it. We'll see how many errors I have. I cannot read what the error is. Let me see. It doesn't like the fact that I'm setting an empty char. Whoa. Oh. I think I just misspelled it. Is this code so bad your computer won't even handle it? I think I just misspelled a variable.
See, I wasn't spelling variables, and it's like, oh, this one line is wrong, but now it just says like error. And I'm like, for why? And it just says error.
Yeah, I get an error when you set a character equal. It says empty character constant, but it's not a constant.
And we finish those changes to that thing, I'll upload it to the drive.
Okay.
Yeah, I don't, Andy. I don't. There's got to be some way, but I don't know how you just set it a character equal to nothing.
So what is this code supposed to do again?
Don't do nothing. Do equal to
What
back
No, we're supposed to.
forward slash I think
like,
either forward or backslash
Oh, it's like a
0.
console?
That's an ultra. Like
Forward slash what?
0. Because forward slash n is like new
I
line.
forget what it's
Yeah.
like,
Slash 0 is
on
the null
busy
char.
or when you're not busy.
So you use the
One of
null
them.
char. Or I use the null char. You can use anything as null if you want, but
Okay.
I use that like
Cool.
setting int equal to 0.
Okay. So yeah. So I did this wrong. Do you guys want to change initially setting the single character to?
Other backslash. The other one.
Oh.
I forgot which one is forward slash. Yeah, that one. See how it's
Ah.
a cool color now. And that'll work.
Yeah, that compiled.
Yeah, there is no like quote unquote empty character.
That's weird that mine compiled regardless, but okay. Like,
I mean, it's fine. I mean, you can assign it to nothing or assign it to something. You just can't assign it to 2 empty quotation marks.
Yeah. Which is what I was trying to do.